that as well, because if you filter out after the waveform has already been generated and filter out those sidebands, you then make it the case that the amplitude of the signal is no longer constant. It has variations in time over the time scale of each one of the symbols being transmitted. And that means that your amplifiers need to be very linear. If you have AM on the signal, you need a linear amplification. The GFSK approach, on the other hand, is applied before the waveform is generated. It's applied to the frequency changes, and that means we can maintain a constant amplitude, and that means even if your amplifier is not very linear, you will not generate extra sidebands. So filtering a RTTY signal can clean it up somewhat, but you better have a good linear amplifier or you'll regenerate those sidebands. That's of interest as well. So what about this contesting mode? Just a few things about that before we finish up here. The idea was to make it somewhat like RTTY for contesting, but faster and better in the sense that it would work with weaker signals. And I don't know whether it's cheaper or not, but maybe. No, in any case, faster and better is the aim. So we're going to use message types, the same as those that are used in FT8, which include, of course, some special message formats for contesting. We'll stay with the 77-bit payload then, and the 14-bit CRC, and the low-density parity check code, which can encodes 91 bits into 174. We're going to speed up the rate at which the signals are transmitted, so that the transmission lasts only about 5 seconds instead of 12.5 seconds. And we're going to use only 4 tones instead of 8 because we'd like to keep the bandwidth as narrow as possible. And it turns out 4 tones is a good compromise for that. Going all the way down to, say, 2 tones would not be any additional advantage. 2 tones and 4 tones both use the same bandwidth because the 4 tones transmits 2 bits after all, so you only have to send half as many of those symbols. Anyway, so 4 tones is a good compromise, and that's the one we ended up with. So that the symbol transmission rate, instead of being 6.25 baud, is 20.8 baud. And in order, sort of in exchange for this faster transmission rate, the signal-to-noise ratio limit, instead of being minus 21 dB, is about roughly minus 17.5. We give up about 3.5 dB for this increase of speed. The bandwidth then of the signal, instead of being 50 hertz, is about 80 hertz. Once again, because we have GFSK modulation, we have these very steep skirts. Here's what the signal looks like. There's an FT8 signal and an FT4 signal compared, again showing the very low side lobes. And finally, let's see, we did do one sort of practice contest on the air. We had a special rally time when lots of people got on the air, and there's what the waterfall screen looked like when we were doing this practice contest. That was a little over a month ago, about 6 weeks ago. It turns out it was possible to work about 60 stations in an hour in that contest. And I think that was, we were all learning our way because we hadn't had any practice doing this before. The actual rate could be up to a little over 100 per hour using the FT4 modulation. You'll notice that in the spectrum down at the bottom there, again, all these spectra have nice sharp edges. They don't overlap much. There's no strong side lobes. That's a big plus. I mentioned the fact that we have been testing the decoders with a wide range of different propagation models. Here's just a quick plot of that. The vertical scale here is the decode probability, and the horizontal scale is signal strength. So this is FT8, which we say decodes down to about minus 21 dB. So here's minus 20, here's minus 21. At minus 21 dB, with good propagation, the probability of decoding the signal is about 0.5, 50%. And that's the way we've defined these sensitivity thresholds. The threshold that we quote is the one at which you have about an even chance of decoding the signal. If the signal is a little bit stronger than that, you'll almost certainly decode it because these curves are so vertical here. So a little bit stronger, even 1 dB more, and you have an 85 or 90% probability of decoding, and so forth. As the propagation conditions vary, the limits may be somewhat different. And for example, on these two curves correspond to this one and this one. High latitude, moderate conditions. We get down to this limit, around minus 15 dB. Low latitude, disturbed conditions are roughly the same. High latitude, disturbed conditions over the pole, through the auroral zone. Notice the curve down here. No decodes. What is the reason for that? The reason is because high latitude, the propagation model for high latitude disturbed conditions is such that the actual broadening of the signal is greater than the space between the tones for FT8. And therefore you can't make out which tone is which, and the probability of decoding is essentially 0. Here's the same thing for FT4. And notice that in this case, the high latitude disturbed conditions is not so dismal. It's this curve. It's not very good, but it still means you've got a 50% chance of decoding all the way down to minus 6 or 7 dB or something. And you'll occasionally decode signals much weaker than that. All the other propagation models are significantly better. And why is this difference for FT4? It's because the FT4 symbol rate, instead of being about 6 baud, is about 20 baud. And that means the symbols, the stability doesn't have to last as long, and the tones are spaced farther apart. The tones are 20 hertz apart instead of 6 hertz apart. So a bigger chance of decoding even under disturbed conditions. And I'll finally just mention where the weak signal limits turn out to be for all of the different modes in WSJT-X. To conduct an SSB QSO, you need a signal-to-noise ratio on this scale of something around plus 10 dB. The signal needs to be above the noise, and you've got to hear it pretty well. That means something like 10 dB is a minimum. RTTY can get you down below the noise a little bit because the signal is significantly narrower. MSK 144 is better still, and so forth. And you'll notice that right about in the middle are both of these modes, FT4 and FT8. It appears that for many different types of ham activity, that's kind of a sweet spot. It's a good place to be. If you need even more sensitivity than that, for example, for whisper type modes where you might be using only a few watts, or for EME, where your signal path has a very large attenuation ratio, then you need to go to these other modes like JT65 or QRA64. Those get you down to minus 25, 27 dB. Whisper gets you all the way down to minus 31. So that's basically the trade-off that you have. Is you're trading bandwidth for sensitivity, basically. Let me just say a few words about ethics, digital mode ethics. Okay. How much power should you be running? You should use enough, that's right, but not too much. So the whole thing works better if you don't try to be louder than everybody else. You just want to find a clean frequency and not use it not be greedy about it. Same thing for the spectrum. We've done all we can to keep these signals as narrow as we can to make it possible to put a lot of them into a narrow bandwidth. Maybe we've done too much in the way of concentrating all the activity into a few narrow slices of spectrum, and there's no particular reason why most of the 20-meter band should be empty and everybody crowded in 3 kilohertz. So we simply may have to find a way to spread out a little bit more. There is one big advantage, of course, and that is that you can tell if the band is open without tuning around. You set the frequency, and if there are any stations there, you know you can work people. How much automation is okay? Well, that's the problem that obviously is before us now. It's not hard to make the system run by itself, but we've resisted the temptation to do that, and we think that in some sense, robotic QSOs are not real QSOs. But that's a judgment call. If that becomes a real issue, which maybe it is becoming at some level, what should we do about it? We've made the software open source because it seems like that's part of the ham spirit, and we'd like to work on these things together with others that are interested in doing it. And although currently there are 3 people that are doing most of the actual programming that ends up in WSJT-X, there are lots of people who have read the code and understand it and have used it in various ways and perhaps have made their own modifications for their own use but not contributed back to the program. All of that is fine, and it seems to me that's all consistent with the general type of activity that we should encourage in ham radio. But it also means it's very easy for somebody to get in there and make circuits around the ways in which we have prevented the system from operating as a robot. And that's pretty easy to do, I have to say. And I guess I said that I was going to show this screen somewhere else later today, but here it is now. If you've worked one of those guys, you've probably worked a robot. And how do we know? Because those call signs get uploaded to PSK Reporter 24 hours a day, 7 days a week. It's pretty obvious. Either these guys are some kind of superhumans that don't sleep, or I'll leave that on. I was going to end by saying see you on the air, but I should leave that on the screen. Very kind, and I probably should have left a few minutes. I think we're just about at 11 o'clock, but I don't think anybody has to run instantly. If there are a few questions, I would be happy to answer some. Okay, over here.
I recently worked with an Austrian call sign in Germany,
Yeah.
and I worked at the grid station also to sugar aid stroke. So both of us had the wrong call sign.
Ah, yeah.
So you didn't get a report.
Yeah. So the question is what? Okay. So the new modes can use special call signs. One call sign can be special. The other call sign cannot be special. 2 special call signs cannot work each other with these modes. So you can make it work if you work hard at it by using the 13-character single free text messages, but it will not work with the automated sequencing. You have to get in there and do it by hand, basically. That's just a limitation. Okay, over here.
Did you see any way to use these modes for doing research in the field of very low signals which originate from HF mobile transmitters, low efficiency? And the second part of the problem is we really do not know very well the angle of incidence, I'm going to say the elevation angle.
Yeah.
Do you see any chance to tackle that problem using these kind of modes?
Okay, so the question had to do with whether any of these modes could be used for detecting, measuring signals from very low power stations that may be mobile, or for measuring the angle of incidence of incoming signals. I think the best modes for that kind of purpose would be whisper, and you're not in that sense trying to make QSOs, you're trying to make measurements, and whisper is good for that. If you have looked at the exhibition hall, look at the soda beams installation there. They have a little gadget called the Whisper Light, and many people have used that for making accurate measurements of antenna gain, that kind of thing. I think that's a good way to use one of these modes. Okay, other questions? Okay, here. Yeah.
The only thing about FT4 is what kind of implementation regarding contest programming. And what I see now, the only thing works more or less with N1MS. So, I mean, you want to use
Yeah.
FT4 for the contest, but I don't see the progress
Yeah.
within contest program.
Good, that's a good question. So is WSJT-X going to be the contest program, or will you integrate it with N1MM or some other contest program that is mature, has been developed over years, is convenient to use for contesting? The answer right now is